Welcome to Atiigah Tech Academy. Today we'll continue our applied electricity video tutorials, and today we'll be looking at delta star transformation. And today this will be the last subtopic for our unit 1. We started with a lot of things: resistors and series, resistors and parallel, and we are now covering the delta star transformation. Okay. Okay, so with delta star transformation, this tutorial will cover what delta star transformation is and why it is useful, and we'll also look at how the formulas for converting from delta to star. So in this video, we'll explore delta star transformation. It is a fundamental concept in circuit analysis that simplifies a complex electrical circuit. So with delta star transformation, realize that sometimes resistors, you can't tell whether resistors are in series or they are in parallel. So that is where delta star transformation comes in. Whenever you can't really tell whether these resistors are in series or these resistors are in parallel. If they are not in series, they are not in parallel. That's where delta star transformation comes in. And we'll also take a step-by-step tutorials to solve examples on on delta star transformation that will really help you to understand the concept of delta star transformation. So whether you are preparing for exams or you want to really strengthen your understanding on circuit analysis, this tutorial will enhance your understanding of circuit simplification. So please don't forget to like, share, and subscribe for more videos. Thank you very much, and I encourage you to work till the end because I'll be giving some tips at the end of this video. So kindly watch to the end of this video. Okay, so let us get started. Okay, so we are going to first of all look at what a delta network is. So when we say a delta network is simply the arrangement of three resistors where one terminal of a resistor is connected to another terminal of another resistor. So in this case, we call those as a delta network. So we can say this is a delta network. So realize that this terminal of the resistor is connected to this terminal, and one terminal of this resistor is connected to this terminal. So we name this circuit. When you see a circuit like this one, because really the terminals are connected to themselves. So this is a delta network. So sometimes in a question you might also see it like this. You might see it like this triangle like this. This is also a delta network. We call this a delta network. It's three resistors. You realize that there are three resistors here with each of their terminals connected to each other. So these resistors you don't even know, because this resistor, we can say R1, R2, and R1. We can say they are in series. We can also say they are in parallel. So how do we solve them? That is where the delta star transformation comes in. So this is a delta. So this is a delta network. So I want you to be able to identify a delta network. So this is a delta network, and this is also a delta network. So let us move on. And so moving on to our star network. In some books we call it star, and some books they call it Y. So note the Y junction. You see that it looks like a Y junction. So it's an arrangement of three resistors where all the resistors have a common point of connection through one terminal of each resistor, while the remaining terminals are unconnected or connected to elements other than the other two resistors in the star or arrangement. So you see, all the three resistors have a point that they are connected to, but the end of the resistors can be connected to other elements or maybe different things. They are not connected back. So when you look at this circuit, we can say RA and RC are in series or parallel. We can't say there because there's nothing much to say here. And aside this is one way of representing a delta network. And we also star, and this is also another way. So you see this circuit. this one and this one, they are the same, just that they've redrawn it. It's a different way. So you can represent it as this. A star network can be this or this. Those are the two ways you can represent star networks. So moving on, we will now learn how to, if it is a star network, how do we convert it to a delta network? If it is a delta connection, how do we convert it to a star? So when you are able to convert it from one form to the other, it simply makes your simplifications easy. So we'll look at delta star transformation. So we realize that this one, our A here, this one here, this A, B, C is a delta. This is a delta. And I want to transform the delta to star. So a delta can be changed to star and vice versa using the following relation. So I can change a delta to star and I can also change a star to delta. But in this first side, we'll look at how to change a delta to star. So this is a network, a delta network outside. So you see that the delta resistors, they are numbered R1, R2, R3. And the star network is RA, RB, and RC. So how do we convert delta to star? So to convert delta to star, let's say if I want to now calculate RA, I'll say my RA is equals to which resistors. I look at RA here, looking at RA, which resistors are opposite to RA, which resistors are at the left and right of RA. That's one thing, how you can. So RA here, the resistors that are opposite to RA here are, our resistors that are opposite to RA here is our R1, R2 and R3. So to find RA is simply R2 times R3 all over the sum of all the resistors in the delta network. The sum of all the resistors, it becomes RA is equals to R2 times R3 divided by R2 plus R3 plus R1. So that is how I find RA. Because look at it here, it's the opposite resistors. This is how you can simply, don't chew this formulas. Me chewing formulas, I don't like to memorize formulas. So I like to always understand how it is, so that in exams, if anything comes, I can easily get my formulas without trying to memorize. So it's simply the opposite resistors, R2 times R3 divided by the sum of all the resistors. Then to also calculate for RB, let's calculate, okay, let's go for RB first before coming to RC. Calculating RB, which resistors are at the left side and the right side of this thing, RB? So we realize that it is R1 and R3. So we can say RB here is equals to R1 times R3 over all the sum of all the resistors in the delta network, that is R1, R2, R3. So RB also becomes R1, R3 all over the sum of the resistors. That is how we go. Then we also come and calculate RC. So to calculate for RC is also which resistors here are at the left side and the right side of RC. So it's R2 and R1, because those are the ones opposite, the left and right. That's how I used to get it, the left and right. So that is, this is also R1 and R2. So RC here is equals to R1 times R2 all over R1 plus R2 plus R3. Then this is how we convert a delta. You see the bigger triangle outside is the delta, and this is the star. That's how we convert a delta to star. We converted this delta to star. So after converting it, I can now clean this delta network here. I can clean, since I've now converted it to star, I can clean here. I can clean this and clean this and clean this. So I now know my RARB, and I fix it back in my circuit to simplify my expression. So let us go to our next series 2. So here we are now converting a star to delta. How do we convert a star to delta? Realize that this is our star here, this is our star, and this is our delta outside here. So with our delta outside, we want to convert this star to delta. How do we do that? So let's say to start with R1. So starting with R1, to find R1, we look at the resistors that are facing R1, the resistors that are directly facing me, facing R1. So which resistors are facing R1? We realize that RB and RC are facing R1. So we simply say R1 is equals to the RB plus RC is equals to RB times RC all over RA, the opposite resistor, the one that you didn't pick. You see, since this one and this one are facing it, since this one R1, RB and RC is facing it, so you sum them and you multiply them and you divide it by the opposite resistor, the resistor that is not facing it, the opposite resistor far away that is not facing it. That is how to do it. Equally, to also find R2, we look at the resistors that are facing R2. RA and RC are facing R2. We add RA, RC, then and we times it, we multiply it, and we divide it by RB. So here is also equals to RA, because RA is facing it here, plus RC, which is also facing it, plus the product of the two resistors facing it, all over RB, because that is the resistor opposite to it. And to also find R3, this R3 here, which resistors are facing it, RA and RB, right? So it's RA plus RB plus the product of RA and RB divided by RC. Then this is it. So this is how we also change a delta to star. So that is, we first one we change a star to delta. So in a question, no one will tell you that use delta star transformation. When you see the delta, you have to choose whether you are going to use delta star or you are going to use um, delta delta star, or whether you are going to use delta star, you are going to convert the delta to star, or you are going to convert the star to delta. It will all depend on you and the question. So let us take some examples, then we really get to. This is our first problem on delta star transformation. It says, what is the effective resistance of the circuit below? Realize that there are two delta networks, the bottom one, this bottom one, and the upper one. If you choose to solve this one, you get the same answer, and if you also choose to solve this one, you get the same answer. So I want you guys to solve it using the top delta. You convert the top delta to star, and I'll convert the bottom delta to star. So doing that, we'll input our star, and they said we should name it RA, RB. So I choose my RA here, my RB here, and my RC here. Please, you can choose to name this RARC anyhow, but I just choose to name it this way. So you can choose to name it anyhow you want. So we realize that to calculate for RA, we said we should take the opposite, the resistors that are opposite to RA, which is 10 times 20, divided by the sum of all the resistors in this delta, which is 10 plus 10 plus 20. So RA is equals to 20 times 10, just as I said, the opposite resistors, divided by the sum of all the resistors in the delta, 10 plus 10 plus 20. Then to calculate RB is also this, the opposite resistor, 10 and 10. The product of the opposite resistor, 10 times 10, divided by the sum of all the resistors. So to calculate RC is also the product of this top resistor, 10 times 20, divided by the sum of all the resistors in this delta, 10 plus 10 plus 20. Then we are done. So after doing this, we've now solved for RA, RB. We've converted this delta to star, so we can clean the delta. We now just clean this delta out. Then it will leave only the star. So I'll clean this one, clean this one, clean this one, and clean this. So it will now be left RA, RB, RC, and this 20, this 10, and the whole of this circuit. So redrawing our circuit, we come and get something like this. So after getting this, I just fixed the value. We found RA as 5, so RA was here 5, RB as 2.5, RB here, and RC as 5. That is why RC is here. And we realize that the 10, this resistor, this 10 and the 2.5 are in series, and the 20 and the 20 and the 5 are in series. So we add them up. After adding them up, we get our new circuit as this. We have 12.5 in parallel with 25. So we realize that this one and this one are in parallel. We resolve them. So after resolving them, that it will become 12 in parallel with 25. So it will become 12.5 times 25 all over 12.5 plus 5. But we realize that it's also in series with this, with the 5. So after resolving everything here, this and this are in parallel, but it's in series with this 5. That's why I added the 5 here. So it becomes 5. So we get our final answer as 40 over 3 ohm. Then we redraw our circuit. So our final circuit now simply becomes this. So we realize that our 30 ohm here is in parallel with our 18.3 because this and this are in parallel. Then we solve that. So solving that, it becomes 40 over 3 in parallel with this. So 40 over 3 times 30 over 40 over 3 plus that, which becomes 120 over 3 ohms. So basically you realize that when you came from this complex circuit to this final small simple circuit. So this is how we solve delta star transformation. This is the most tricky part. If you are able to figure out this part, you redraw the circuit, identify your resistors in parallel and resistors in series, resistors in parallel, then finally just find your total equivalent circuit. So if someone will have also decided to solve the topper part, after solving the topper part, you still end up coming to get the same answer. I hope you guys are getting it. So leave your answer in the comment section. Thank you. Problem 2 says we should find the input resistance of the circuit between the terminals A and B, and these are the terminals A and B. This is A and this is B. So those are the terminals A and B, and we have our resistors here. What do we realize? We realize that there is a delta network here, and there is also a delta network here. So here you can decide to do any, you see there's a delta network here, but when you come here to, there's a star network here. So you can decide to either use delta star or you can use delta, but me, I want to convert this delta to star. I want to convert this delta to star. This is also a star network. You see that this 10, 20 and 5, this is star network. So someone can also see this question and decide to convert this star to delta and also solve the circuit. But always look at what will make the circuit simple for you. So me, I'll prefer to convert this delta to star so that it will make the circuit simple for me. So doing that, I do it this way. Then I'll name here as my RA, my RB, and my RC. After doing that, I simply apply my principles. So RA, which resistors are opposite to RA? This is the delta network we are considering. The total resistance for the delta network, the sum of all the resistors, is 5 plus 25 plus 15. So basically, we have RA is equals to our 5 times 15 all over 5 plus 15 plus 20. So finding that, we have this. So this becomes our RA. And to also find RB should be equals to the opposite resistors, the resistors that are at the left and right. So which is 5 times 20 all over the sum of all the resistors, which is the same as 20 plus 5 plus 15. So we get our total RB to be equals to this. So after getting our RB, we also have to calculate our RC. And to calculate RC is the opposite resistors. RC opposite, which are resistors are opposite to RC, 15 and 20. So 20 times 15 all over 20 plus 15 plus 5. Wow. Then we simply get this, as simple as that. Then we have to now redraw our circuit. Redrawing our circuit, I always encourage you to redraw your circuit, because when you redraw the circuit, you really get to understand how things. So we are now down solving this delta, so we can clean this 5 clean this 20 and clean this 15 and this branch and this branch. We clean them. So after cleaning them, we get our new circuit as this, because I just cleaned these things. I get our new circuit as this. So realize that this 30 is in series with our 7.5. That was our our RC, and this 10 is in series with our RB, which is the 2.5, and our RA 1.9 is also there. So we can just combine this as this. We just add this to this, this to this, and realize that they are still in parallel. So after doing that, we will draw our circuit. So after adding that, it becomes 37.5 in parallel with 12.5. So 10 plus 2.5 and 30 plus 7.5. That's what we get. So realize that this and this are in parallel. So we have to resolve this to get a series circuit. So resolving this, the 37.5 and 12.5, we come and solve it in parallel. So doing it in parallel, this is the answer we get. After getting this answer, we redraw our circuit again. So our 25 is now in series with our 9.4. This one is equals to 9.4 in series with 1.9. That was our RA. Then we simply add them. So our input resistance now becomes 25 plus 9.4 plus 1.9. So which is now equals to 145 all over 4 ohms. So that is how we calculate our total resistance here, the input resistance. So the input resistance here is 145 over 4 ohms. So moving on forward, let us solve our another problem on this. Find the input resistance of the circuit between the terminals A and B. So this is our B, this is our A. We also realize here in this question that, see, this is a delta network here. This is also one delta network here. As I said, someone can decide to solve this delta network. I'll also decide to solve this delta network, and we'll end up getting the same answers. It doesn't matter about which one you choose. You end up getting the same answers. So I'll solve the one at this side. So solving them, I'll convert this delta to star. So I have, let me name my RA here. Here is my RA. Here is my RB, and here is my RC. After naming them, I now have to calculate for RA, RB. And here, let us look at something. Our total resistance in this circuit, this is 50, this is 10, this is 40. So the total resistance in this delta circuit is 100. So to find RA is equals to this opposite to this. 40 times 50 all over 40 plus 10 plus 40. So finding that one, 40 times 50 all over the sum. So here we have 20 ohm. And calculating for RB, this is our RB. 50 times 10, which is our 50 times our 10, the opposite resistors. 50 times 10 all over the sum of the resistors in the delta. 50 plus 10 plus 40. Then to also do the same, RC, the opposite resistors over the sum. So RC now becomes 40 times 10 all over the sum, which we get 4 ohms. Then we redraw our circuit, because after doing it, we can clean this. I can clean this, clean this, clean this. Then now redraw my circuit. Redrawing my circuit, I get something as this. See my 4 ohms here, my 60 was already there, and my 5 ohms and my 20. Then what do I realize? I realize that the 30 and 4 are in series, so I add them to get 34. So we add them to get 34 here. Then we add them to get 65 here. 60 and 5 to get 65. So after adding them, I realize that the 34 and 65 are in parallel. So I resolve them in parallel. Then finding them in parallel, this is how we find them in parallel. I'll get 221 over 2210 over 99. So getting that answer, I now realize that when I resolve it, I will now redraw my circuit. Redrawing my circuit is also equals to 22.3. Redrawing my circuit is this, rather everything here is in series. Everything is in series. Then I now add everything up to find my total input resistance. So adding everything up, this is what I get. After getting this, that is becomes my final answer. So I saw this complex circuit that I didn't know which resistors are in series, which resistors are in parallel, but changing the delta to star made everything simple for me here. So let us take our last question, then we'll be good to go on delta star transformation. So going on, this is a question that they gave it to us. I know some of you have seen this question in your reference book and you are finding it difficult to solve it. So they said find the input resistance of the circuit below. What do we realize? We have to first of all look at some things here. Realize that this 1 ohm and this 1 ohm are in series, so let's add them up. So 1 plus 1, it becomes 2, and this one and this one are also in series, so 1 plus 1, it becomes 2. I realize that. So we'll redraw our circuit again. So this, we realize that I will now have a delta network here. But what do we realize? We realize that this one and this one are in parallel, because this one and this 2, 1 and 2 are in parallel. 1 and 2 here are in parallel. So we resolve that circuit again. So after resolving that circuit, I'll redraw it again. So after resolving that circuit, this is what I get. After resolving that circuit, and I want to convert. After resolving that circuit, you see that this is a star network. It's a star network here. This 1 1 1 is a star network here. So I want to convert that star network to a delta. That is why I brought my RA here, my RB here, and RC here. I will choose how to do my orientation. So I want to convert the RA RB to a star network. So to convert the RA RB to star network, I will now do it this way. So RA, to find RA, which ones are facing RA? It is 1 and 1. So it becomes 1 plus 1 plus the product of 1 times 1 all over the opposite one, which is 1. You remember the formula when I was doing the explanation. I hope you get it. So our RA is equals to 1 plus 1 plus 1 times 1, which is equals to 3 ohms. To get RB here too, RB, which ones are facing RB? Realize that this one and this one are facing RB. 1 and 1, they are facing RB. So to find RB is also the same thing as this. 1 times 1 plus 1 times 1 all over 1. That is RB. And to also find RC, we do the same. It becomes 1 times 1 plus 1 plus 1 all over 1. So it becomes like this, which was also equals to 3 ohms. So what do we realize here? We realize that when they give you a network, a delta network, and all the values are the same, you realize that A, B, C will all get the same answer. You see that we are having the same answer for all of them. RA, RB is the same answer. So now let us, since we now found everything, we can now clean here. We can now clean all these 3 resistors and we are done. After cleaning them, this is what we get. We now put our 3 3 3 there. And let us look at something here. We realize that these 2 and this 2 and this 3 are in parallel. Look at it. This 2 and this 3 are in parallel, and this 3 and this 2 over 3 are also in parallel. So let us resolve them. So after resolving them, we get this. So after resolving 2 times the 2, here it is 3 is parallel to 2, this 2, and here is 3 is parallel to 2 over 3. So after resolving them, this is what we get, 6 over 11. And after resolving this, this is what we get. And after resolving this, this is what we get. You see that? So after getting those ones, we now realize that this 1.2 and this one, they are in series. So you can just add them up, and this are in parallel. So we add them up. So solving them, the 1.2, I said, as I said, they are in series. Adding them up, we have 99 over 55. Then after that, the 99 over 55 is in parallel with this one. The whole of this is in parallel with this. Then we solve it to get 32 over 9. then we redraw our circuit again. So we realize that it will be left with this one and this 32 that over 29 that we found, and in series with this. So redrawing our circuit, we get our circuit to be this. So it becomes 1 here, 1.1 and 1. So to now find our total input resistance, it is just the sum of everything. 1 plus 32 over 29 plus 1 is equals to 90 over 29. And the 90 over 29 is equals to 3.1034 ohms. So basically, this is how we solve this problem here. And this was our last problem on delta star transformation. So thank you very much for watching, and kindly subscribe, like and share. I know that this side might be somehow complicated, but when you take your time, watch the video. Like, you don't have to watch it once, watch it over and over again, repeat it, repeat it. If you don't understand, watch it again and listen to the explanations well, because it really goes a long way to help you. Thank you very much, and thank you for watching. Kindly share, subscribe, and for more tutorial videos.